Hello everyone. In this video, we are going to determine the inverse of rational function. This is the second part. I will put the link of the first part in the description box below. Let's take this first example right here. Find the inverse of the function f of x is equal to 3 over 2x minus 5. There are steps that we need to follow in order that we can determine the inverse of any function. The first step is to replace f of x with y. So in this problem right here, this f of x will become a y. The second step is to replace every x with y and replace every y with x and solve for y. So pretty much like this y here will become an x, and that is equal to 3 over this x will become a y, so that becomes 2y minus 5. And then part of this step is to solve for y by itself. So pretty much we are supposed to isolate y by itself on the right side. In order that we can do that, we can multiply both sides by 2y minus 5, so that's 2y minus 5, and multiply the other side as well by 2y minus 5. So I multiplied both sides by 2y minus 5. If we do that, we can cross out the 2y minus 5 and the 2y minus 5. So on the left side, we are left with 2y minus 5 times x is equal to 3. We want y by itself, so we can go ahead and divide both sides by x. So I'm going to divide this by x. I will divide this by x. I can cross this out. So on the left side, I am left with 2y minus 5 is equal to 3 over x. Again, our target is to have y by itself. So then we can go ahead and I'm just going to rewrite it up here. Okay, since we want y by itself, I can go ahead and add 5 to both sides. So plus 5 and plus 5. So we are left with, that's gonna be 2y is equal to 3 over x plus 5. We want y by itself. Since we have a 2 here, so we can divide both sides by 2. So I will divide this by 2 and I will divide this by 2 so we can cross this out. We are left with y is equal to 3 over x plus 5 over 2. And we can move on to the third step. Replace the y of the equation solved in step 2 with f negative 1 of x. So pretty much I can rewrite this as f negative 1 of x is equal to, that's gonna be 3 over x plus 5 over 2. And this is the inverse of this function right here. So that's the inverse right there. Now, we can actually simplify this. We call this as complex fraction. So complex fractions are actually fraction in a fraction. So there's a fraction, at the same time, it's part of a big fraction. We can simplify this by adding these two. So that would be 3 over x plus 5, and that is over 2. So I can go ahead and make their denominator the same by multiplying this side with x over x. So I just multiplied x over x in there. So then our equation would come out 3 over x plus 5x over x, and that is over 2. Since these two are like terms already, they have the same denominator. So then we can go ahead and add them up. So that would be 5x plus 3 over x. So what I did was I added, since they have the same denominator now, we can add these two. That's 5x plus 3, and then their common denominator is x, and that is over 2. So then we are going to use the rule for complex fractions. I'm going to put that up here. So complex fraction, if we have a fraction inside a fraction, so we have a over b, and that is over c over d. In order that we can simplify complex fraction, what we do is we write the top, which is a over b, times the reciprocal of the denominator, which is d over c. So in this problem right here, we remember that this one has an invisible denominator of 1. So then I can go ahead and rewrite this as this will be our a, and this will be our b. So I'm going to rewrite that as a over b. So this would come out. Okay, so what I did here was this is the A and this is the B. So I wrote it up. I wrote it down here. So that's A over B. So I go ahead and write A over B. And then this one right here is 2 over 1. There's an invisible 1 right here. And we can represent this as our C and our D. And in order that we can simplify this, we are going to flip this around. We're going to multiply this by d over c. So that would become 1 over 2. So then we can go ahead and simplify this. This would come out. So I'm just going to show the work up here. So we can simplify this as 5. We can multiply the 1 here. So that becomes 5x plus 3 over x times 2 is 2x, and this is our inverse. So then we can go ahead and change our y to f negative 1 of x, and which is the notation for the inverse. So this is the simplified version of this inverse right here. So these two are actually the same. They are actually equivalent equation, which means that they are just the same. These two are the same. At this time, I would encourage you to pause this video and try this problem out on your own. And when you're done, and pause it and check your answer. Okay, so we go over the problem here. First step is to replace f of x with y. So then I can go ahead and write y is equal to negative 5 over 3x plus 2. Then we move on to the second step. The second step is to change or replace every x with y and replace every y with x and solve for y. So this becomes... So then from here, we need to solve for y by itself. I'll show you the other way of doing this. We remember that this one has an invisible denominator of 1. So then we can go ahead and cross multiply these two. So what I did was I multiply these two terms. So then from here, we can go ahead and solve for y by itself by dividing both sides by x, dividing this by x. So then we can cross this out. We are left with 3y plus 2 equals 5 over x. By the way, this is a negative 5. So that's a negative 5 over x. So then from here, we can go ahead and isolate y by itself by subtracting 2 from both sides, minus 2 and minus 2. So then we are left with, that's gonna be 3y equals, because we can cross that out, so 3y equals negative 5 over x minus 2. So then from here, we can go ahead and have y by itself. I'm just gonna rewrite it. Okay, so what are we going to do is we divide both sides by 3. I divide this by 3, so we can cross the 3 out. So we're left with y is equal to negative 5 over x minus 2 over 3. So changing this to its inverse notation, we can rewrite this as f negative 1 of x is equal to, it's gonna be negative 5 over x minus 2 over 3. So this is the inverse of this function right here. Okay, since this is a complex fraction, we can actually simplify this by using the rule for complex fraction. We got here the rule for complex fraction. So what are we gonna do is we make sure that their denominator are the same, so that I can go ahead and show the work up here. So that would be, I can multiply the 2 by x over x, so their denominators are the same. So then we can go ahead and come up with an equation that's negative 5 over x minus 2x over x over 3. So that from here, they already have the same denominator x, so we can simplify this as negative 2x minus 5 over x, and that is over 3. So remember, this is our a, this is our b, and this is our c, and the d here is the invisible denominator 1. So then we can simplify this by rewriting it this way, multiplying it. So that would be a over b, so that is negative 2x minus 5 over x times d over c. So again, this is our c, this is our d, so we flip it, we get the reciprocal of this, so that would be 1 over 3. So then the final equation for the inverse here would be f negative 1 of x is equal to, that's negative 2x minus 5, because we multiply it by 1, so it stays the same, and that is over 3x. And this is the simplified equation for the inverse. So again, these two are equivalent equation. They're just the same. They just come in different form. So this is the simplified version and this is not the simplified version. Did you get the same answer as this? Good. Perfect. If you found this video helpful, hit like and subscribe for more math videos. See ya!